we go. Start us off. Go ahead and just get this stuff thrown away right off the bat. Well, that was too easy. I feel like something's going to pop out at me. All right, so let's start with let's do this right here. Okay. Do this if you still need that help remembering that step. All right, so what might have stalled you out a little bit is 8 times 7. What is 8 times 7, everybody? 56. We put the 6 and carry that 5. And then 8 times 5, that's one of our 5, so it's a little easier to remember that 8. Mason, what's 8 times 5? 40. And then just add that extra 5 there, so 45. So your first row should be 456. Okay, check that. And then we're done with that 8, and we put our 0. 2 times 7, everybody? 14, put the 4 and carry the 1. 2 times 5, everybody? 10, one more makes 11. Add those up. So your bottom row, your, second row, 1,140. Okay. Add those up. 1,596. Okay. All right. Let's do one division problem. Okay. Yes or no? Is there going to be a remainder on this problem or not? If you think there's going to be a remainder, raise your hand. We're just kind of guessing right here. Remainder? If you don't think there will be a remainder, raise your hand. All right, see if you're right. Work the problem and see if you're right. check it with multiplication if you've gotten finished. Just another minute. Alright, so how many 5s can we get out of 8? Or Kayla, what's the most 5s we can get out of 8 here? Just 1. So subtract that, and get 3, and we bring down the next digit, which is another 3. Ishmael, what's the most 5s we can get out of 33? 6. Which would be what? 30. And we subtract that, we get 3, and then we bring down the next digit, which is a 5. What's the most 5s we can get, Isabel, out of 35? Say it one more time. 7. I think that's what you said. 5 times 7 is 35. Did we have a remainder? No. How might you have known from the very beginning? I'm not going to have a remainder here. Yeah.
Because you're dividing by 5 and the 800 it has a 5 at the end.
Yeah, right. This right here, that digit is a 5. Any number that ends in a 0 or a 5 is going to have 5 as a factor. It's going to go in evenly. Okay? So, but just to double check, 167 times 5. 5 times 7 is 35. 5 times 6 is 30 with 3 more. 5 times 1 plus 3 would be 8. There you go. All right, so that worked. Yes?
I got it wrong.
What happened?
Instead of 33, I accidentally put 35 because I brought down the 5 instead of.
Oh, I don't know if I've heard that this year, that mistake. That instead of bringing down the 3, you grabbed another digit, but he grabbed the 5 by mistake.
That happened to me before.
How easy is that to happen? What?
It happened to me.
Did it happen sometime? Okay.
I messed up with my multiplication.
Just got multiplication facts wrong. And I appreciate y'all sharing these mistakes when you catch them, because it does help us all be like, oh, yeah, try to remember not to do that. Okay? Mistakes help us grow. Mistakes help us learn. Okay? And then y'all help each other with them, so that's great. Okay, one more little kind of get going problem right here. This one has more to do with what we've been learning about lately. You take 39/7 and turn that into a mixed number. It is an improper fraction right now. What is an improper fraction? What is an improper fraction? Charlotte, what's an improper fraction? What's going on when the fraction's improper? How do you know? If I was looking at it, how could I tell? Somebody help her out. Let's put it into words. Brandon?
The top number is bigger than itself.
Yeah, the top number is bigger than the bottom number. The numerator is larger than the denominator, and that's an improper fraction. Okay, go ahead and change this to a mixed number. About what a mixed number is. A mixed number has a whole number and a fraction with it. So if I'm going to figure out what whole number goes with this, I've got to do what? I'm saying these things to get you to think about how to get started. Some of us are trying to think how to get started here. How many times can you pull a whole number out of that? Numerator. In this fraction, How many sevenths do I need to make a whole number? Yeah. 5 sevenths will make a whole number?
Oh, no, 7.
7 sevenths, okay.
I thought you were talking about something else.
Okay. So, you need your number bond. And how many times can you pull out 7 sevenths from 39 sevenths? What's the most you can pull out? Yeah. Okay, 5 times. Because 7 times 5 is 35. That's getting pretty close to 39 without getting too big. So 7 sevenths, you might have lumped them together, and that's fine if you did. But if you didn't, your number bond might look like this. And then how many are left over? If I take 35 away from 39, I've got how many left over?
4 7.
Yeah, 4 sevenths are left over. So these are all whole numbers. 1, 2, 3, 4, 5, and 4 sevenths. So that is your final answer right here. Okay. All right. What questions do you have already this morning? When can we do some more math? I heard that question. I don't know who said it.
That's my question.
That was your question? But you want to do math to get you going. Yeah, I can. Yeah, you can. Yeah. All right. I don't know if we're gonna get hard today. I think this is just a little extra. All right.
Can we have nap time? Nap time, yeah.
I'm gonna make sure that I let the pre-K and kindergarten teachers know that that was a request, and they're gonna be like, I told them years ago.
I didn't enjoy it. I never fell
Yeah.
asleep.
Okay.
I just laid there.
Me and my friend used to throw pickleball at each other.
Uh-oh.
And I would move my foot back up to the
Uh-oh.
green. Cause I
Y'all need to quit telling me these things. Okay.
You used to be a bad kid?
No.
All right, time out.
I used to be.
Personal foul on the offense. However that goes. Stop talking on this part of the room. You know, I need to wear my ref outfit sometime. Okay. Hey, whoops. Okay. Let me go back to our chart. We are getting back into adding and subtracting fractions for a little while.
Yes.
Everybody's favorite. Last time we were here and we did addition, it was almost like we barely touched it because it was so simple. It was a whole number and it was a fraction, and basically all we did was go and move them close together.
That was so
Okay, and it was super easy. Today, they're just showing you different situations with fractions. Today we're going to be adding a mixed number and a fraction. Okay, and we're just adding. We're just staying with that. We'll get to subtraction later this week. There's a little bit more involved with subtraction. Okay, so go ahead and clear your board. But before you even write, let's just talk through this one problem, and then we'll start doing some for practice. Okay, tops are on our mark. Top is on it because it lays there, it dries out. Okay. All right, so you have a mixed number. You have a fraction. Okay. These are eighths. We know that. Now, how are we going to do this? If you saw this problem, what do you think could be something that would help you solve it? I'm going to tell you, you kind of already have the knowledge for this up here that we've already kind of talked about. Look at it. What do you think would be the easiest way? And I've seen this done different ways, and so I may show you a few different ways to do this. Choose the one that works best. Charlotte?
The heart method?
Well, we're not comparing fractions. Heart method, all those things we did on Friday, we were comparing, trying to see which one is largest. Now we've gone back to adding, okay? So we're not trying to figure out a strategy to see which one is the biggest. What do you think?
You could do 3 plus 3 and it equals 6, and then they'll add the denominators.
Okay. And then that 2 part, what would you do with it?
Just leave it the same.
Just
Unless
keep it in the answer. Okay.
Unless if it goes like 8 eighths, if it added up to 8 eighths.
Okay. Okay. Did you want to add something different?
1 is like 8/8, so 2 is just 8/8 and 8/8.
Mm-hmm.
And so you could do 8/8 plus 8/8 plus 3/8 plus 3/8.
Mm-hmm. You know what you did is just the same as when we do mad, is it's 8 2 times plus the 3 that are already there plus these 3 more. Okay, so one way is just to add the fraction pieces and move over the whole number. That's what Reagan was talking about. Another way, even though he said it a little differently, is what we've already known, the mad, where we turn this into an improper fraction and add them all together. But what do you think when you get to the end you'd have to do with your final answer? Yeah.
Turn it into a mixed number.
You have to turn it back into a mixed number. You know, we kind of start with a mixed number, we undo it, add up the other fraction with it, and then turn it back into a mixed number, because most places are going to want your final answer as a mixed number, unless they ask for an improper fraction. And most of the time they're not going to. They're going to ask for a mixed number for your answer. Okay, so let's try both of those ways and let's see what we get for our final answer. Let's see if we get the same thing. All right, so we'll work through a few of these together just to make sure we remembered this. It's been a few days since we've done some of these things. So clear your board if you haven't already, and let's work together. Stay with us so that hopefully this is making sense to you. Okay. We've got 2 3/8 plus 3/8. I'm just going to move here to give us a little more room. 2 3/8 plus 3/8. So we're doing this problem twice, so you probably want to write up high for one and then let's save space for the second way. Okay, go ahead and get that problem on your board. Okay. So at first Reagan said, the whole number, let's just move over. And then add the 2 fraction pieces. Well, 3/8 and 3/8 is what? 6/8. Okay. The only problem I see you having here, and maybe you can figure it out. Something might happen when you add the fraction pieces. Think what could happen as many fraction problems as we've worked already. What might happen that's going to make you have to do something different towards the end? What do you think?
Put the 2
Well,
at the beginning. At the end.
no, we want it like that as a mixed number. Okay, what?
You might get your adding wrong when you add like 3/8 plus 3/8. You might get it.
Well, you could make a mistake. But even if you did all your adding correctly, what could happen?
When you're adding them, it could turn into a mixed number.
If these 2 fraction pieces, when you add them together, add up to an improper fraction, you're not going to have a whole number and then an improper fraction. So if that ever happened, you don't throw the 2 away, of course. But you would have to change that to a mixed number and add the 2 to it to have one final complete answer. And so do I think this is always the best way to go? Be careful, because I'm afraid you might forget to do that changing of the mixed number at the end. Okay? But if you recognize that this is going to be smaller than 1, that's pretty quick, isn't it? That was super simple. Okay? All right, let's try the other way. So rewrite the problem. 2 3/8 plus 3/8. Okay. Now this time we're going to change that mixed number to an improper fraction. And this is probably the most common way to do this. We're going to use mad right here. And so write your new improper fraction just right under it. We're going to rewrite the problem once we change this. So how do we do mad? Help us out here. What are we going to multiply? I know we multiply because of that m. Brandon, what are we going to multiply together?
3/8 and the 2 wholes.
Okay, but which part of 3/8 do we multiply with? When we're changing a mixed number to an improper fraction, and we've practiced this. Do you remember what to multiply? Help him out. What do we multiply?
3.
The 3 doesn't get to multiply. Okay? Yeah. Yeah, we multiply the denominator by the whole number. 8 times 2. What is 8 times 2? 16. What do we add? What do we add to it? Yeah.
3.
The 3. So 16 and 3 more is, no, it's 19. Okay. So now we have 19/8. There's our brand new mixed number. That's why we took a time out several days ago to practice changing a mixed number to an improper fraction and an improper fraction to mixed number, because right now it's just a step inside of another problem that you've got to know how to do. All right, now we're going to add the 3/8. You see how that just became super simple? What is 19 plus 3 more? Yeah. 22/8. But are we going to leave it like that? I wish we could, but we can't. We're going to have to switch it back to a mixed number. That's with the number bond. How many times can we pull out 8/8? Twice, I heard. Okay. That gives us 16 of those 8s. How many would be left if we pulled 16 away from 22? Yeah. Okay. So our whole number just became 2, or our mixed number, 2 and 6/8, which is the same.
The top was definitely easier.
Yes, except if we had to do that extra step, it would have taken a little longer. Okay. Some of the addition and subtraction that we're getting into this week does take a little longer because you've got some of these steps where you've got to change it and then you got to change it back. Yeah. Okay. You did. And I may show that. I don't know if you want to look at Will's board. Okay. Let me move this. You can put it down, and I'll put part of that up here. Some people might love the calling this MAD and multiplying, adding, and putting it over the same denominator. Let me have your eyes, guys. Y'all sit up, okay? We're all tired this morning, but we're going to make it. If you know that 2 is 8/8 and 8/8, right? Because that's 1 and that's 1, right? And we have 8s here. And then we have this 3/8. So 2 is this and this, and then we have the 3/8 from right here. Just add those together. You see what we got there? Do you see how we got that right there? This is 8/8 and 8/8, or you could even go ahead and say it's 16/8. Okay. 16, 17, 18, 19, 19/8. We got the same thing when we did math. Because look, 8/8, 8/8, 8/8. It's just repeated addition. We just did it 2 times. If this had been a 9, 8/8 plus 8/8 plus 8/8 plus 8/8, you know, until we had 9 of them. That's why we multiply right here. It's repeated addition. But some people feel more comfortable with that. That's fine to do. Okay. It's just one more way of doing this whole process we've been doing. And then this would have turned into that. Okay. All right, so that is the main gist of what we're doing today. There is one little extra thing we're going to talk about today. Since we've just worked one of these, let's do a couple more of them before we move to that extra thing. Let's go right here. Now this one, we're going to work together and we're going to do it two ways. We're going to do it the same two ways. There's a reason for this, okay? So at the top of your board, write 5 2/4 plus 3/4. Okay? All right, get with me. Now let's work this Reagan's way first. Remember how she said to pull over the whole number and then just add the fraction pieces. Okay, so I pulled over the 5. I just pulled it over here. And then when we add those fraction pieces, what are we going to get? What are we going to get? 5/4. Can we leave that like that? No. Okay. So you'd have to take that 5/4 and change it with a number bond. Okay, so this is 1 1/4, and you'd have to add it to the 5. Okay, so plus 5 more would equal 6 1/4. There's just so many steps in there on the back side that I'm afraid if you get it that way and you want to get it that way, that's fine. But you cannot forget to change that if this is what happens. Because you cannot leave this like this. Y'all see why? This is an improper fraction piece right here. Can't do that. All right, let's try it the other way. 5 2/4 plus 3/4. Change this with MAD or by repeated addition. Now this is 1 because there's 5 of them. I'd rather multiply. You see what I'm saying? Okay. All right, guys, we're going to change it. It looks to me this morning like we need to change it together, some of us. So stay with me right here. What is 4 times 5? Everybody? 20 plus 2 more? 22. We have 22/4 plus the 3/4 that's part of that problem. Okay, and so our final answer is 25/4, which is very much an improper fraction. We got to change it. So go ahead and change it to a mixed number. Cannot leave it as 25/4. How many times can we pull 4/4 out of here? You might have written 24/4, done it all together. That's okay if you did that. 1, 2, 3, 4, 5. Or you could have separated them all like that. Okay. And how many are left? That's 24 of them. So how many are left? 1/4. Okay. So 6 1/4. And that's what we had gotten before. It's just way easier to make a mistake on that other way. So this is probably safer for us right now. Okay. Y'all know there's more than one way to do a math problem. We try to teach it the simplest way a lot of times so that you avoid a lot of ways of making a mistake. Okay. But different ways work for different people, so and I know that. Okay. All right. So basically, you're going to change the mixed number to an improper fraction, and then add everything together and switch it back to a mixed number. Okay. What if? Let me let you have one by yourself. Okay. So let's get rid of that. I've done a lot of helping. I understand it is Monday morning, but at some point we gotta wake up. Okay. Go ahead and add that together. You're gonna switch that mixed number to the improper fraction first. Then you're gonna add in the 4/5. Then you're gonna switch it back to the mixed number. Alright, so when you are all done, you're going to have a mixed number as your final answer. Okay, because you changed it back to a mixed number. Where's your final answer? Okay. This isn't that. This isn't that. So we're not going to change this to an improper fraction. I'm going to add that to it. Not very easily. Right, we need to do it the other way. Change this to an improper fraction first. I think I said that, guys, and all of a sudden everybody's doing it the other way when I said not to. So just listen. Okay. Oh, why did I do that? I'm so busy thinking about the final answer. Alright, we gotta make that mixed number mad. Okay. What does this turn into? If you did it the other way, you're going to have an answer that's off if you've forgotten the parts. So we're not doing it that way. We're going to change this first. Yeah.
37/5.
This turns into 37/5 because 5 times 7 is 35 plus 2 more is 37. That's the very first thing you should have done. Then add the 4/5. And what will you have? 37/5 plus 4/5 is what? Mason? 41/5? 41/5. Yeah. Okay, and I leave my answer like that. No. How many times can I pull 5 out of 41? That's real close to a fact family. Yep. 8 times. In fact, you can do it like this, because I know 5 times 8 is 40. And then I'd have 1/5 left over. Or you could pull 5/5 out 8 times. Okay, so your final answer is 8 and 1/5. Sometimes it is a lot of work to get to the answer. It's just part of it. Okay, let me go ahead and say this. On our problem set today, that first way that we I can see I need to go ahead and just make the rule. We're not going to use it. Okay? We're going to do all of our problems like this today because we need to practice this way before we step into that other way. Okay. I want to show you something right quick before we move on. If I have this fraction right here, okay, I want you to clear your board, put the top on your marker. Okay. A few times today we're going to see a different kind of problem. And I want you to be able to recognize it. Some of this is going to take just kind of reasoning. Okay? If I have this fraction, and I ask you the question, how much more do I need to get to 1 whole? You can picture the number line. You can picture a pizza, one of these. Okay? So let's use that right now. Let's just use a visual at first. Okay? That says 1/4, correct? Alright, so if I have 1/4 of the fourths pizza, kind of picture the rest of it. How much more do I need to get to 1 whole? What would I need to have a whole pizza right there? That's what I'm asking. Alex? 3/4, yeah. All of these, right? And if all of these were there, I'd have the whole thing. And that's 3/4. Okay? See? There we go. So, all right, let me try this again. If I had this as a fraction, and I asked you, how much more do I need to get to 1 whole? How much more, if I've got this much, how much more do I need to get me all the way to 1 whole? And if you need to picture it, here's our 8ths. Pizza, pictured on a number line. I've gone all the way to 3/8. How much further is it to the 1 whole? Okay, trying to get you to think. Yep.
5.
It's 5 more 8ths, isn't it? Because 3/8 and 5 more 8ths is going to equal 8/8, which we know is 1 whole. Okay, let's try another one. Now, this looks different. It's not just that cute little fraction by itself. We like the good old days when it was just a little fraction all by itself. Yeah, well, that's the reality is we're not always going to have that cute little fraction all by itself. It's going to be with a mixed number sometimes. So here's the question. The question has changed just a tiny bit. You can still picture the number line. You can still picture pizzas. I just don't have as many to use to show you this, okay? If I've got 3 1/8, how much more do I need to get to the next whole number? If you're counting, what's the next whole number after 3? Yeah, 4, okay? So think of the number line. Picture it in your mind. Here we get to the 3 on the number line, the regular old 3. The next whole number is the 4. It wouldn't matter if this number was 307. The next whole number is 308. Okay? So we've got 3, and then a little bit past 3, we've got 3 1/8, a little bitty 8th. How much more do you need to get to 4? The next whole number. Yeah. 7/8. If I had 7/8 more, I'd make it to 4. To the next whole number. Question?
If you like that plain little fraction, you can just imagine the 3 is gone and just have 1/8.
That's exactly what you could do. Imagine this is gone for a minute. What do you need to get to a whole number? Okay. Now, if you're needing to know what that whole number is, you'll have to go just 1 up from that right there. All right, so why are we doing this? I want to show you what the math problem would look like if this type of thing were in a math problem. I bet you've seen math problems like this before. Maybe not with fractions, but they have a blank in them. All right, I'll put it on my screen. Let me put it up here. If we had 4 4/5 plus blank plus something equals 5. Okay? This is exactly what I was just asking you. Exactly. It just wasn't in a math problem. Okay? Now it looks all scary and official because somebody printed it on their computer on a slide. It's the same thing. Okay? If I have 4 4/5, how much more do I need to get to this whole number? And 5 comes right after 4. So you could do what Will said. You could imagine the whole number's not there, you know. But you got to realize, is that the next whole number? Okay? And it is. So what do we need? Just 1/5. Just one more little fifth is going to get me to 5. Okay? So that would be your answer.
Are we gonna do this?
We're going to have problems like this, yes. That's why we're working on this. If you had a number line and you had 1, 2, 3, 4, 5, you could keep going. Okay, I just want you to see this. And if I was at 4 4/5 right here, so 1, 2, 3, 4, and if these were fifths, okay, y'all see that? I could cut the whole number line, but I'm just saving us some time. Okay, let me have your eyes up here. If I'm at 4 4/5, so I go to 4 and then I count 4 more fifths. 1, 2, 3, 4. So I'm right here. This is all we're asking. That's where I'm starting, 4 4/5. How much more do I need to get to 5? Just this one little, let's change its color so we can see it. Boop. Just that one little boop right there. If I'm at 4 4/5, I'm here. How much more do I need to get to 5? That's what that math problem is asking you. Just one little fifth. Okay? So that number line helps you see what we're talking about. All right, let's do one of these together. So on your board, oh, wait a minute. This is really scary. Hold on. Are they allowed to do that? I mean, the equal sign is not where it's supposed to be. Are they allowed to do that?
Oh yeah.
Are you sure?
It's just backwards.
No. Is that okay?
Yeah.
Yes, it's okay. I have seen some people that are just good at their math problems going along, and then it's like this, and it totally throws them off. This is the same exact thing except Miss Wendy's weird equal sign. Okay? It's the same exact thing as if I had it over here. Equals 6. Okay? 6 equals 5 1/8 plus what? What does 5 1/8 need to get to 6? How much more do they need to get to 6? How much more? I'm going to call on those folks whose hands are up. You got 5? You got 5 and 1/8. How many more 8s do you need to get down to 6? 2. There you go. All right, Jayla, what do you think? 5, not 5. A little bit more than that. Because these are 8s. Okay? I think we did have fifths a minute ago, but these are 8s. Help her out.
7. I agree.
Okay. Guys, think about, I need however many it takes to get this right here to a whole number. And if you've already got one of those 8s, how do we get to 8 8s? 7 more. Okay? So we need 7 8s right there. Because if 7 8s was added to that 1/8, this would become one whole, and then you got 5 with it. 5 and that one whole would make 6. That's what we're shooting for. Okay? Right. Sometimes when we first hear stuff like this, it's a little confusing. I think the more you see it, the more it will make sense. All right. I think that is all of our practice. I tell you what, we will see both kinds of problems on our problem set. Sometimes we'll have to change to a mixed number, or always do that. Sometimes we'll have to change to an improper fraction first, add it, change it back to a mixed number. Sometimes we're going to be filling in the blank like that. But what we're showing you here is this is another way to think about it, okay? All right, so let's go ahead and put our whiteboards and markers away. And we will take our break and then come back and jump into our problem set.